Good afternoon everybody. Just previous session we learnt about the shear force and bending moment diagram for a simply supported beam with the application of loads of UVL and concentrated moment. So what we did previous cases, we had solved this particular problem in the previous session. So we had solved this problem, application of UVL, then we had solved the application of concentrated moment, then we had solved the application of once again UVL but of two different triangles for a simply supported beam. So now we had solved all the combinations of the loads with individual applications, but right now let us solve the combination of the loads and solve more typical numericals over here right now. Yes, here now the given beam is of simply supported beam up to 2 meter length, that is at the up to center of beam, means up to the half of the span. No external load is acting, but on the other side of the span UVL, application of UVL is there. And let us see how the shear force is varying along the length of the beam and how the bending moment is varying along the length of the beam. So step number 1 for our case is to find out the support reactions. Before we found out the support reactions for a given beam, the UVL is converted in terms of the equivalent point load, that is half into 10 into 2. Now step number 1, sigma h is equal to 0, only RAH is there is no external load is acting, hence RAH is equal to 0. Apply next sigma V is equal to 0, RAV and RB are of upward but this UVL acting downward, so RAV plus RB is equal to half into 10 into 2, that is equal to 10 kilonewton, that we can obtain over here. RAH is 0 and RAV plus RB is equal to 10 kilonewton. In these equations once again these two unknown RAV and RB, hence to obtain the answers of RAV and RB we have to take a moment at a certain one point. Let us take the moment at A. Figure. Take a moment at A. While we take a moment at A, the moment because of RAH and RAV are 0. This next load is of UVL half into 10 into 2, which is acting a moment at distance of 2 plus 1/3 into 2 clockwise moment. So plus sign half into 10 into 2 into bracket 2 plus 1/3 into 2, while this RB creates anti-clockwise moment, has minus sign, so minus RB into 4 is equal to 0. By simplifying this equation we achieve RB is equal to 6.67 kilonewton. By putting the value of RB in this equation we obtain RAV plus 6.67 is equal to 10 kilonewton and we achieve RAV, that is RA, that is of 3.33 kilonewton. So our next intention is to plot the shear force diagram. See the figures, let us be understood over here right now. Reaction 3.33, that is of RA, RB is of 6.67, Reaction itself for a simply supported beam are the value of shear force at that particular section. So this RAV section left upward treated as positive 3.33. It is here very much important to visualize that between this point to this point there is no load. So the variation of shear force is given by horizontal straight line, 3.33 horizontal straight line up to the center point of the beam, up to the point at which the UVL starts. Next, our intention is to find out the variation between this region, how my shear force diagram goes change. Carefully visualized. The given load is of UVL, hence the variation of shear force having a parabolic nature. So now let us draw for this particular portion over here. This is a given beam, given load. The reactions are 3.33, 6.67, and this ordinate is of now. We know up till now this one, we found out this one 3.33, and this value is of 6.67. This distance is of 2 meters. Now take a section over here, XX, take it from the right side, distance X. So the figure looks like this. So what we did up till now, we are taking a section from the left side, but right now we are taking the section from the right side. The reason behind is that the triangle nature. If we take a section from the left side, then we have to remove this portion. We have a trapezoid. Yes, we can solve, but slightly lengthy procedure will be there. Hence, to avoid that lengthy procedure, we will take from the right side, distance X. So for 2 meter, if this vertical ordinate is of 10 for X, it is how much? It is 10x by 2 is equal to 5x. So this ordinate is of 5x. So shear force at XX is equal to, it is note down very interestingly, if I will take a section, then on this side is left side, on this side is right side. So section left downward, section left downward treated as negative. So with this we achieve the value as 6.67 minus half into 5x into x. So we achieve the answer as 6.67 5x square minus sign by 2. Now let us put x is equal to 1, then shear force at 1 from this right side is equal to 6.67 minus 5 by 2 is equal to, we achieve 6.67 minus 2.5, that is 4.17, and this is of downside. See, don't look at this positive or negative nature right now, because this is of downside. This at 1 meter we achieve 4.17. So we have to join these ordinates by a parabola. So visualize the nature of parabola. This is the distance at which shear force is 0. So we have to equate shear force at x is equal to 6.67 minus 5x square by 2 is equal to 0. So we achieve 6.67 is equal to 2.5 x square, and we found out the value of x is equal to 1.633 meter. So we achieve this is of 1.633 meter, and this is of 0.367 meter. This ordinate is of 0.367. The point at which the shear force is 0, we will obtain maximum bending moment. So go for here. So visualize over here 0.367 over here on this slides PPT. .367 over here on the PPT, please visualize. Yes, 0.367, and be careful, this nature of parabola is of this kind. Let us go for the next bending moment diagram. At A, at B, both are the supports. The value of bending moments are 0 at both the locations. Between A and C, at the center point, there is no load. The variation of bending moment is given by inclined straight line, and the magnitude is of RA into 2. RA is of 3.33 into 2, 6.67 is the ordinate at C point. Carefully visualized. Now, between C to B, the given load is of UVL. We know the variation is given by parabola, but the nature of cubic parabola is much important, because the maximum value of bending moment taken place is within this 2 meter region. So let us plot this portion right now over here. This ordinate is of this one, two meter, 2 meter, 3.33, 6.67. We plotted up till right now is of this 6.67 with the plus sign. So now let us take at what is the value of ordinate at 1 meter from the right side. So if we take this 1 meter, this is of 5 kilonewton per meter. So bending moment at right side of 1 meter is equal to RB into 1 minus half into minus half into 1 into 5 into the CG distance is of here. I want this distance 1/3 into 1, 1/3 into 1. So this gives me 6.67 into 1 minus 5/6 is equal to, so we achieve 6.67 minus 5/6 is equal to 5.84 kilonewton into meter. Now, but the value of maximum bending moment maximum, which has been taken care at 1.633, and that is equal to, so what I have to do, I have to find out the ordinate right now over here. So if I will take a section, (1.633 meter), this is the distance. I have to find out this ordinate. So for 2 meter, if it is of 10 kilonewton per meter, for 1.633 it is how much? So 1.633 into 10/2 is equal to 5 multiplied by 1.633, which gives me 8.165. So this ordinate is of 8.165 kilonewton per meter. So what is value of RB? That is of 6.67 into 1.633 minus half into 8.165 into 1.633 is the area of triangle acting at the CG over here. I want this distance into 1/3 into 1.633, and we achieve the answer is of 7.262.